is one thing that has made both of those possible, a discovery that has catapulted man into the modern world. Have a look at this. Look around you. The modern world is built from steel. More than any other single invention, it has shaped the way we live. But to truly understand this wonder material, we're going to have a history lesson from an old mate of mine in a damp shed in Kent. I'm here with Owen Bush, one of the country's top blacksmiths, and together we're going to figure out how to turn this ridiculously heavy lump of mud into some kind of steel. Owen, what do we do?
Well, this is iron ore from the Forest of Dean, and as you can see, it's an iron oxide-rich stone rock.
To get the metal out of the ore means breaking it up and cooking it in a forge with some charcoal. After a day or so, what comes out is this. Called bloomery iron, the metal is revealing itself, but it's still full of unwanted muck called slag. It's really soft and quite brittle when slag is in there. To turn it into something useful takes hours more heating and hammering, each whack squirting some molten slag from the white-hot metal. So it's like, in a way, like smacking a donut and the jam squeezing out, and the rest of it kind of staying there.
Interesting analogy, but it is similar.
This repeated folding and hammering either squeezes out the last of the slag or pushes it into very thin strands. The result is wrought iron. For thousands of years, this is as tough as metal got. And that seems more like the kind of metals I'm used to, but still appears slightly soft. But it's definitely something that I can imagine ancient man being very, very pleased with. And this basic metal really transformed the ancient world, allowing man to make lethal weapons and innovative tools. But to make the modern world, we needed something even better. We needed steel. What ancient blacksmiths discovered was that in order to turn soft iron into hard steel, it required a very special ingredient. Poo. I had to hop into that field and collect a big fresh lump of this, because apparently it turns iron into steel.
It's what you need to make steel.
This better hadn't be a wind-up.
It's not a wind-up, we're dead serious.
One lump or two?
Two.
I'm not saying that they use this technique nowadays, but until just a few hundred years ago, blacksmiths would cook their wrought iron in an oven with poo, leather and charcoal. Now we know all of these are simply convenient sources of carbon.
What we're trying to do is get some of the carbon out of the materials we're putting in there, the poo, the leather and the charcoal dust, and get it into our iron and turn the iron into steel.
And it's the addition of carbon to the iron that makes it steel.
Yeah.
It seems a strange place for a revolution to start.
Sometimes things start from the bottom. Okay, stone clear?
Yeah. Incredibly, it's only in the last 50 years that we've begun to understand metals at an atomic level and realised that their properties come from their crystalline structure.
Lay on the brick, Jim. It may crack in the snow.
And metals form a very special crystal structure because the crystal is movable in the sense that one layer or part of the crystal can move across and lock into a new place. And that's effectively what you've got when you bend something. It's the crystals moving without breaking that allows the metal to bend so smoothly. And knowing this points the way to how to make the metal harder. So what we want is to do something to that metal where it's actually harder for the layers to slip past each other. And what the ancients discovered was dropping some impurities in there made a difference. Carbon, they found, was particularly well absorbed by iron, and it formed iron carbide. Now imagine this is a slightly irregular iron carbide. I'll drop that in there, put it together. When I try and move the layers, they don't move so easily. And that is effectively hardening it. It's harder for them to move around. And so what they've made there is not iron, it's a new material. It's steel. Meanwhile, after a few hours in the heat, our poo cooker was ready.
Looking good. It might still be hot.
I feel almost archaeological. It's warm, but it's not too hot.
Put it up. We've still got loads of unburnt carbon, which is a really good sign. It means that actually no oxygen got in there.
So these little guys here, we put them in as iron, and they've come out as steel.
Yeah, it sounds different, doesn't it?
It does. It sounds harder. That's like got a higher ring to it. And the poo is
completely disappeared.
It's in the steel.
It's actually now in the steel. I mean, that's astonishing.
For hundreds of years, it was the desire to produce ever harder and sharper blades that drove the ancient blacksmiths forward.
Now this is steel. It's no longer iron. It's harder and tougher and well on the way to becoming the most important material on the planet. Right, let's see how it performs. Chopping.
Rope, no problem. Wood, very impressive.
And now, there is barely a mark on that blade.
The hammer just bounces off it, and it's very stiff too. I can hardly bend it. If simply adding an impurity like carbon could change iron into steel, metallurgists began wondering what else they could do.
In the last century, another revolution in steel occurred. Foundries were able to maintain very accurate temperatures, and new metals were added to the steel to create alloys.
Metals like chromium, manganese and vanadium
Would change the crystal structure of the steel. Now, chrome would produce a tougher, more corrosion-resistant metal. The manganese here would make it less brittle, and vanadium would give it more strength. These alloyed steels enabled us to do things we could simply never do before.
Starting with a lump of ore, man has found a way to create the most influential material in our modern world.